So this is chapter 5, the beginning of chapter 5 on statistics. So we're going to start off today with a review and a preview of what we'll be looking at in this class, or in this chapter. So statistics is the name given to the branch of math concerned with the collection, analysis, and interpretation of numerical data. The collection of data by various methods we've covered in other courses. We've talked about the population or taking a sample from the population. Once the data is collected, it's analyzed in a variety of ways, and we have talked about those variety of ways in previous courses with the terms averages, mean, median, and mode. So for example, when students receive their unit test marks, they often ask, what's the class average? I never tell you what the class average is because it doesn't really matter how the class did, it matters how you did. I worry about the class average. Once data has been collected, it's useful to describe the data by one central value. There are three different ways that we can describe data, three measures of central tendency. There's the mean, and the mean is the one that we tend to gravitate to. It's what we normally call the average. When we are talking about the mean of a population, we use the Greek symbol mu. That's this little, looks like a long-tailed U. If we are talking about a sample, we use the letter X with a line over top of it. Again, sometimes these do get interchanged. We use mu when we're actually dealing with X. The mean of a population and the mean of a sample are both calculated the same way. And it's calculated by adding all of the data values and then dividing by the number of values that were in that set. So if I was calculating the class average, let's say, of exam marks for your class, I would add them all together and divide by 9 because there's 9 students in the class. Then there's median. Median's determined by finding where the middle is. So the first thing I have to do is I have to sort my data into numerical order from low to high. And then I find the center. If there's an odd number of data values, so if there's 11 values in the set, I'm only going to have one center part. If there was 12 values in the set, when I try to get to the middle, I'm actually going to have 2 numbers. So I find the average of those 2 numbers. And then there's the mode. The mode is the data value that occurs most frequently. And it is possible to have no mode, meaning nothing occurs more than once, or to have multiple modes. So some examples of when it might be more prudent to pick the mode or the median. Mode, the best example I can think of is if you are in a store and you're trying to calculate which size is most popular. That's when you're going to be worried about mode. I'm not going to take all of the shoes that I sold of the sizes, add them together and divide. I want to know which shoe size I sold the most of because that's going to drive my ordering in the future. Median sometimes works when we're trying to get rid of some of those outliers. So the example I use for this sometimes has to do with reporting of salaries. When companies say that the average employee makes this much money per year, they're talking about mean. And that might not actually be true because in any company, the bulk of your workers tend to earn a lower income. And then you have those upper personnel, your executive personnel, that earn huge salaries. And if I take their big salaries and I average them off with the little people, it adjusts things. So going back to the example that I know most strongly was a report that I had to do like 20 some years ago. And it was on before the liquor board did their privatization. And there was an article that said that the average employee made like $45,000 a year. Well, that was a very misleading statement because if you said the average employee, people thought of the person that they went and got their stuff from at the store. And that's not what that person made. Like very few of those people ever made, like maybe the managers made $45,000 at that point in time, but most of the non-managerial staff were lucky if they made half of that. And it was because, again, they took all of those executives and put them into the pool. So a median measure might actually be more appropriate because that's going to be giving everybody's salaries, putting them in numerical order, and then finding the middle. So those high salaries at the one end are going to cancel out the low salaries, and you're going to get a better reading. So let's look at class example number 1. The data shown is to the nearest minute for high school students to drive to school on each of the last 10 days. So I want you to calculate the mean driving time for the data. So how would I find the mean? What would I do? How do I find the average of this set? Okay, so I want you to do that. Add them all up and divide by the number in the set. Third, if I add these all together, what did I get? 142. And what would I divide by? So on average, I can say it takes about 14.2 minutes to drive to school. The mode is the one that occurs most often. Which number occurred most often in this set? 15. It occurs twice. Now, if my data doesn't have a lot of outliers or things that is going to skew the information, my mean and my mode and my median, they should be approximately the same. The only time that they're not is when I have those outliers that really adjust or can put an impact on the data. So let's look at class example number 2. Haida Keys unit test marks in English 20 and Math 20 are given below. Calculate the median for each. So in order to calculate median, I have to take the English scores and put them in numerical order. So what's the smallest number in this set? Followed by? What's the next one?
65.
Then? After 67? After 71? After 78? And after, then we have 8. So now I want to find where dead center is. So I cancel these two out, I cancel these two out, I cancel these two out. 71 is in the middle. So the mean, or the median for English was 71. So now if I look at the math marks, what's the lowest math mark?
61.
Okay, followed by?
72.
Then? Then?
84. 6.
So again, now I'm trying to find the center. So if I start from the outside and I work my way in, I have two center values. I have 74 and 78. So I find the average of those two. Where's the middle between 74 and 78? 76. So the math mark, the median is 76%. In the third example, if the mean of the data set 10, 4, 7, 12, 9, 4, x, and 6 is equal to 7, find the value of 6. So that means if I go 10 plus 4 plus 7 plus 12 plus 9 plus 4 plus x plus 6 and divide this by 9, because there's 9 values in this set, the answer will equal 7. So I want to solve for x. So the first thing that I want to do is I want to add all these numbers on the top. Do that for me. 10 plus 4 plus 12 plus 9 plus 9 plus 4 plus 6. Tell me what you get when you've got that done.
What's that? Do we add that X or?
Pardon me? Just add the numbers along the top. 61. So I have 61 plus x divided by 9 equals 7. And my goal is to get the x by itself. So I have to think in terms of order of operations. I would take x, add it to 61, and then divide that answer by 9. So if I work backwards, instead of dividing by 9, I would multiply by 9. So I multiply both sides by 9. What's 9 times 7?
63.
How do I get x by itself? So how do I get rid of the 61?
Minus 61.
Minus 61. And what is 63 minus 61? So there's the value of x. Now, sometimes instead of being given a data set, you could be given a frequency set. So the data below shows the number of touchdowns thrown by Jason, who's the school's quarterback during his high school career. So in the first game, he threw no touchdowns. Then he threw 1. Then he threw 0. Then he threw 2. All the way through. So this is game 1, game 2, game 3, game 4. So it says calculate to 1 decimal place if necessary the mean, median, and mode for the number of touchdowns per game. So let's figure out the mean. For the mean, I'm going to add all of these together. So the zeros I don't need to worry about. 1 plus 2 is? Plus 1?
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 5, 6, 7.
What'd you get?
27.
27. How many games did he play?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.
So what's 27 divided by 19?
1.4.
So to 1 decimal place, 1.4 touchdowns per game. Let's look at the mode next.
Definitely 2.
Definitely 2. How many 2s do I have? 1, 2, 3, 4, 5, 6, 7 2s. And then I had 2 3s. How many 1s? 1, 2, 3, 4, 5, 6, 7 1s. And 3 zeros. So the mode, 1 and 2. There's 2 modes. And then the median, I have to put these in numerical order and then find the middle. So the middle, if I have 19 data values, the center comes at 10. Right? Move in 3, move in another 3, into. 1 touchdown per game is the median. Now, the problem with this is because the zeros and the 1s and the 2s and the 3s occur so often,